So dose and duration seem absolutely key, and maybe the individual situation too. Do we see consistent patterns across different types of cancer, or does it vary a lot?
The sources suggest it really does vary. It's not a uniform relationship. Take colorectal cancer, for instance.
Okay.
Observational studies, just looking at people's diets, suggested that getting plenty of natural folate from foods seemed protective. Good thing.
Right.
But when researchers tested this using folic acid supplements in trials, they haven't consistently found that same protective effect. Sometimes they've even raised concerns it might speed up growth if someone already had pre-existing polyps or lesions.
Complicated. What about others? Prostate, breast cancer?
For prostate cancer, there's some evidence, but it's described as inconclusive, linking higher levels of folate in the blood to maybe a modest increase in risk, not a strong, clear link. And for breast cancer, studies looking at dietary intake haven't really found a consistent impact either way.
So that variability just reinforces how complex this picture is.
Yeah.
Okay, let's circle back to the metabolism and that COMT-HFR gene.
Mm.
What about supplementing with methylfolate directly? You said it bypasses that slow conversion step. Is it just better?
Well, mechanistically, it makes a lot of sense, doesn't it? Especially if you know you have that reduced MTHFR activity. Why not just take the form your body needs anyway?
Seems logical.
And some smaller studies do suggest it might be better at lowering homocysteine levels. That's another marker linked to some health issues, especially in people with MPHFR variants. There's also some early evidence suggesting it might be less likely than high-dose folic acid to mask vitamin B12 deficiency.
Masking B12, how does that happen?
High doses of folic acid can sometimes fix the anemia associated with B12 deficiency, but not the neurological damage, so it can mask the problem until it's more severe. Methylfolate might not do that as readily.
Okay, so those sound like potential advantages for methylfolate, particularly for the MTHFR folks. But I sense a but coming.
There's definitely a but, or maybe a caveat. While the mechanism is appealing and those early findings are interesting, the science on methylfolate is still playing catch-up compared to folic acid. We just don't have those really large, long-term clinical trials designed specifically to prove definitively that methylfolate is safer regarding cancer risk compared to folic acid, or that it actually reduces cancer risk.
There's not enough big studies yet.
Not yet. And also, some researchers raise a valid point. Even if it's methylfolate, if you take it in high doses, it's still the active form that fuels cell division. So could high-dose methylfolate potentially stimulate tumor growth if a cancer is already established? Similar to the concern with high-dose folic acid.
Ah, so it might bypass the conversion issue, but maybe not the paradox issue entirely, especially at high doses.
That's the question that remains open, yeah. More research needed, definitely.
Okay. Beyond cancer risk, did the sources mention other health areas linked to folate status?
Yes, they did touch on a few. Folate status is connected to things like mood disorders, cognitive health, even insulin sensitivity.
Mood disorders, like depression.
Exactly.
Yeah.
That MTHFR deficiency we talked about, for instance, has been linked with a higher risk of depression, potentially because you need adequate folate to make certain neurotransmitters important for mood regulation.
So that's why some people explore methylfolate for depression.
That's part of the rationale, yes. It's sometimes used as a complementary therapy. But again, the sources would stress that we need more robust, large-scale research to really confirm how effective it is in that context.
Okay. Let's bring this into a real-world policy situation. Your source mentioned the UK deciding to mandate flower fortification with folic acid. How does that fit into this complex picture we've been painting?
Yeah, that's a really clear example of public health policy grappling with this. The UK did decide recently to mandate adding folic acid to non-wholemeal wheat flour, probably starting late 2026.
And the reason for that is?
The reason is incredibly strong and really undisputed, preventing neural tube defects like spina bifida in newborn babies. The evidence from countries that already fortify is overwhelming. It significantly reduces the number of babies born with these serious conditions. That public health goal is paramount.
A clear major benefit. But you mentioned there was an expert concern flag in the sources about this kind of population-wide approach.
Right. While fully acknowledging that huge benefit for preventing NTDs, the concern raised by some experts is about the potential long-term consequences of exposing the entire population to higher levels of folic acid and potentially accumulating unmetabolized folic acid, especially for those individuals with the MTHFR polymorphisms who don't process it as well.
So it's a balancing act.
It really is. It brings up that tough public health question. How do you balance a very clear, immediate, significant benefit for one specific outcome, preventing NTDs with potential, maybe less certain, longer-term risks for other subgroups within the whole population who will now have this increased exposure, whether they need it or not?
That's a really difficult calculation for policymakers.
Okay.
Let's try and pull all this together. Based on everything in your sources, what are the main takeaways for someone listening about folate, folic acid, and cancer risk?
I think the main conclusion has to be that it's nuanced. You just can't make a blanket statement that one form is simply good and the other bad. It really depends on the form, the dose, probably the duration you take it, and your own individual biology, including your genetics.
Okay, so what are the key bullet points then?
Key takeaways from the sources would be: 1, natural folate and synthetic folic acid are handled differently by the body. Genetics, like MTHFR, matter for processing folic acid.
Right.
2, moderate folic acid intake, like 400, 800 micrograms, generally looks safe for most people based on the big trials, but there are some inconsistencies, and concerns definitely increase at higher doses.
The 1 milligram plus doses.
Exactly. High-dose folic acid has been linked to potential risks in specific situations, like that increased overall cancer risk in women post-childbirth, the non-Hodgkin lymphoma link, and importantly, that increased childhood cancer risk after high prenatal exposure in that specific group. 3, that relationship with cancer seems likely to be U-shaped. Both deficiency and potential excess could be risky, depending on whether cancer's already started.
Got it.
4, methylfolate looks promising, especially mechanistically and maybe for MTHFR carriers, but we really need more large-scale safety data comparing it directly to folic acid regarding cancer risk.
Still questions there.
And finally, getting enough folate from your diet, from actual food sources rich in natural folate, that remains the most reliable and lowest risk approach for most people.
So that U-shaped curve idea, where not enough and potentially too much could be risky, that's really the central concept to hold on to.
Yeah, I think that captures the core complexity emerging from these sources. It suggests there's probably an optimal range for folate status, and going too far below or too far above that range could potentially be detrimental. And crucially, where that optimal range lies might be different for you based on your genetics, your health, other risk factors.
And the practical takeaway for listeners then, what should they do with this information?
It really comes down to moderation, I think, and recognizing that a personalized approach might be needed for some. That old idea of more is always better just doesn't seem to apply neatly here, especially when we talk about high-dose synthetic folic acid over the long haul. Making sure you get enough from a varied, healthy diet rich in folate sources is fundamental.
This has really been quite the deep dive, hasn't it? Taking a nutrient many of us see on labels or in vitamins every day and uncovering all these layers of complexity we might not have thought about. We've looked at those basic metabolic differences, the role of genetics like MTHFR, that really fascinating paradox of folate's role in cancer.
The dose effect.
The dose effect, distinguishing moderate from high-dose findings, the potential of methylfolate, and even how this plays out in real-world public health decisions like fortification.
It definitely shows how even seemingly simple vitamins can have really intricate interactions with our biology and our long-term health outcomes.
Absolutely. So, as you, our listener, reflect on this deep dive, maybe take a moment to think about where folate or folic acid shows up in your daily life. Are you eating fortified foods? Taking supplements? What dose?
Yeah, and considering all this complexity, the individual differences, the fact that nutrients can have these essential benefits, but also potential risks depending on the form or the dose, how might you approach staying informed and making choices about the nutrients you consume? It's certainly something worth mulling over.